These are the examples for Algebra 2A, Credit 2, Lesson 4.1. Lesson 4.1, we're going to be working with circles in problems 1, 2, and 3, and then again in problems 4, 5, and 6. So that's why we have this as examples for 1 through 6. We're going to be writing the equation of a circle. We're going to first identify the center, find the radius, and then use that information to write our equation. All right, so let's go ahead and do that. The center is right here. It's already identified with this point. And all we need to do is determine the coordinates for that point. So remember when we're identifying the coordinates of a point, the first number is our x. So we always start from the origin. And then we need to go to get to this point here, we have to go to the right 2 squares. So that would be a positive 2 because we're going to the right. If we went to the left, it would be negative. And then after that, we have to go down 1, 2, 3 squares. Since we're going down, that's negative. If we had went up, that would have been positive. So our center is at 2, negative 3. The radius is simply the distance from the center to the edge of the circle. So let's count the squares there. Maybe make that a little bit smaller so we can see the squares. 1, 2, 3 squares. So our radius is 3. Now we're going to use that information to write the equation of the circle. Remember that, or recall, or we'll tell you now here, either way, that the center of the circle, of course, this point is x and y, but we're going to use those numbers for h and k. X and y will just stay x and y in our final answer in the equation. So we have x minus h is 2, squared, plus y minus k. Now, k is a negative 3, so careful, we have that double negative there. Minus is part of the general form of the equation, and this negative 3 is what k is. Finally, r squared, the radius is 3, so 3 squared. And so that's the equation of our circle, but we can simplify it with this negative here and also simplifying the 3 squared. So we bring down the x minus 2 squared, nothing to simplify there. A negative becomes a positive, so that's y plus 3 squared. And then finally, simplifying 3 squared, again, when you're squaring a number, you're multiplying it by itself. So 3 squared means 3 times 3, which is 9. And that is the equation of our circle. X minus 2 squared plus y plus 3 squared equals 9. If you look at it, we won't talk too much because we're focused on the examples in these videos. But the equation of a circle, the general form, is basically the distance formula. The distance from the center to, the center to the edge of the circle. And if you think about it, that makes sense because that's what a circle is. A figure where every point on that circle, on that figure, is the same distance from the center of the circle. So it kind of seems to make sense that we would have a variation of the distance formula for the equation of a circle. All right, so again, these will help you with problems 1, 2, and 3, and then 4, 5, and 6 is kind of the same thing as 1, 2, and 3. And so now we're going to jump to an example for number 7. So let's get rid of all of this here. And for number 7, we're going to be given the equation of a circle, but not in standard form. And what they want us to do is write it in standard form and then identify the center and radius and then use that information to graph the circle. So let's go ahead and take a look at our example. We have x squared plus 6x plus y squared equals negative 20 plus 12y. All right, now we can see that, or we can determine, I should say, that this is an equation of a circle. It doesn't look anything like the one we just wrote, but that's what we're going to do. We're going to make it look like that. But even before we start, we know it's a circle. And the reason we know that is that both x and y are being squared and they have the same coefficient, which is 1. So that's how we know it's an equation of a circle. It's not that it's not that, and we're going to turn it into the equation of a circle. We're just simply going to put it in standard form. All right, so the way we do that, first thing we have to do is get rid of this 12y. So we're going to subtract 12y to both sides. And we're going to start organizing things. So we have x squared plus 6x. We have to make this a perfect square trinomial here. So we're going to leave a space to do that. And then we have y squared minus 12y. So plus y squared minus 12y. And we also have to make that a perfect square trinomial as well. And then equals negative 20. So that negative 20 is still on the right side of the equal sign. So let's go ahead now and make these perfect square trinomials. Remember how we do that? We take half the coefficient of x, or half the coefficient of y in this case. So starting with the x, 6 divided by 2. Dividing by 2 is how we can take half of something. 6 divided by 2 is 3. And then 3 squared is going to be 9. 3 times 3 is 9. So we take half the coefficient of the middle term, and then whatever answer we get, we square it. We multiply it by itself. Now, we can't just go adding 9 to one side of the equation because that's what we need to make this the equation of a circle. We're also going to have to add 9 over here. Make that a little bit more clear. Now, same thing with the y. We have negative 12 divided by 2. And again, is it always divided by 2? Yeah, because we're taking half of that amount. And that's negative 6. And now we're going to take negative 6 and square it. Negative 6 squared means negative 6 times negative 6, which is positive 36. Let's make that a little bit better. And of course, if we add 36 to this side, we have to add 36 to this side as well. Now we're almost there. We're ready to put this into standard form. Now what we have to do now is factor this here, but we already know it's a perfect square trinomial. So when we know that we're factoring a perfect square trinomial, there's a little bit of a shortcut. These will factor, since it's a perfect square trinomial, into the same factors. And what are those factors? Well, the shortcut is, well, before we talk about the shortcut, let's talk about what we would be thinking if we didn't know this was a perfect square trinomial. So we would need two numbers that add to 6 and multiply to 9. And it turns out those numbers are 3 and 3. 3 plus 3 is 6. 3 times 3 gives us 9. So now what if we knew, and we do know that it's a perfect square trinomial. So what we can do is just say x, the sign of the middle term. And now what number did we square to get that 9? Or we could say, what's the square root of 9? Well, that's 3. And so we have x plus 3 squared. Now, is this a shortcut to factoring? No, only because we know, or only if I should say, that if this is a perfect square trinomial, which these both are, because when we completed the square and added that 9 and that 36, that's what we made them into be. Perfect square trinomials. All right, now over here we have y, but this time the sign of the middle term is negative, so it's y minus. And then what is the square root of 36? It is 6. And so we have y minus 6 squared. Now over here on the right, we've got some simplifying to do. Negative 20 plus 9. Negative 20 plus 9. The signs are different, so we subtract 20 and 9. That's 11. The larger number is negative, so negative 11. And now we're going to add that to 36. Once again, signs are different, so we subtract. 36 minus 11 is 25. But this time, the larger number, the 36, is positive. So all of this adds up to positive 25. And if you want to study that for a second and maybe try those addition problems on your own, maybe pause the video for a second. That would be a good idea. But we're going to erase this. And just so we have room to work here and so it doesn't get confusing, we just put the 25 over there. So now we have the 25, and now we have our equation, and we are done. All right. So now what we're going to do is from that, we need to determine the center and the radius, and then we are going to graph it. So what we're going to do actually is write our equation up here. So we have some room to work and some room to graph our circle. All right, so let's get rid of all of this. So now the center, remember the center is our HK, that's our H, that's our K, But remember, the standard form of the equation of a circle was x minus h and y minus k squared. So if that's the case, in order to determine the coordinates of the center, we have to take the opposite sign of each of these. So the opposite of positive 3 is negative 3, and the opposite of negative 6 is positive 6. So our center is at negative 3, negative 3, positive 6. Now over here, remember, this is not the radius. This is the radius squared. So we have to take the square root of 25, which of course is 5, because 5 times 5 is 25. So our radius is 5. All right, so now that we have that information, let's go ahead and graph our circle. So our center is at negative 3 and 6. Our first number, our x-coordinate, is negative, so we're going to go to the left 3. And then the second number in the ordered pair is positive 6, so we're going to go up 6, 3 and 6. So there we go. So that's our center, left to the left 3, and then up 6. Our radius is 5, so we're going to count out 5 units in each direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. One more time. 1, 2, 3, 4, 5. And so now we've got guide points to guide us in drawing the circle. And remember, you are drawing a circle, so avoid the kind of temptation to make a square or diamond there. So go ahead. And by the way, one good way to draw a circle, I was taught many years ago, is to don't follow the pen, kind of look where you want to go. So let's see if this works here. So I'm looking at the points that I'm drawing to, and not perfect, but better, not bad at all. All right, so there we go. That is our equation that we determined as an example for number 7, and also we have our center with our circle with our center of negative 3 and 6 and a radius of 5 graphed. All right, that is it for lesson 4.1 examples. Good luck with the work. And again, as always, pause, rewind the video as needed. And we'll see you in the next video. Until then, take care and God bless.